Lesson 15.3, Task 3. Find the value of trigonometric functions given the value of tan theta. The identity tan of theta equals sine over cosine can be used to write two additional identities. Multiplying both sides of the identity by cosine gives sine of theta equals cosine of theta times tan of theta. All right, so basically all they're doing is saying if we want to solve for sine of theta, I would multiply both sides by cosine, and that gets sine by itself. So that's what this is right here. Then dividing both sides of sine theta equals cosine theta times tangent of theta. Okay, so that's just an equivalent statement. It's just solved for sine of theta. All right. So this gives the cosine of theta equals sine of theta over tangent of theta. So we have tan of theta equals sine over cosine. We have sine equals cosine times tan. And we have cosine equals sine divided by tan. All right, so given that the tan of theta equals or is approximately 0.482, where theta is between pi and 3/2 pi, find the value of sine and cosine. All right, so what is this telling us? It's saying we've got one of the three given. We want to find the other two, so we're going to use Pythagorean identities. But we also are given theta is between pi and 3/2 pi. So this is the restricted part of the domain that we're looking at. Remember, pi is 180 degrees. 3/2 pi is 270. So 180 to 270, this tells us that theta is in quadrant 3. So quadrant 3 is left and down, so both the cosine and the sine are negative in quadrant 3. All right, it says use the identity sine of theta equals cosine times tan to write sine of theta in terms of just cosine. So sine of theta equals cosine times tan is approximately cosine times 0.482. So we're given tan is this. So we're going to take the formula that we had above, and all we're going to do is substitute this in place of tan. All right, so could the work have begun by writing cosine of theta in terms of sine of theta? Yes, all we had to do was use the other identity. Instead of using sine equals cosine times tan, we could have used cosine equals sine divided by tan first, and it would have just switched it. All right, now it says use the Pythagorean identity sine squared of theta plus cosine squared of theta equals 1 to find the cosine of theta, then find sine. All right, so we're going to plug in what we were given. Okay, so up here, because we have sine of theta, we know that that's equal to cosine times tangent. So in place of sine squared theta, we're going to substitute what we just found. So the 0.482 cosine theta is so that now we only have one variable. Okay, so it's sine squared theta plus cosine squared theta, but we're going to substitute this in place of my sine squared. All right, once we do that, we have a quantity squared. So we're going to take and square each part of that. So the 0.482 squared, we can use our calculator to find out that that's equal to this. So if we do 0.482 and we square that number, we get the 0.23. And the reason they have approximately here instead of equal is because these numbers that are being substituted in are approximate values. When we round those, that means it's not exactly 1 anymore. All right, so we squared the number, and then we still have cosine squared of theta, and then we have plus cosine squared of theta. Now, when there's no coefficient here, it's assumed to be a 1. So since these both have cosine squared theta, these are considered like terms. So I have 1 plus 0.232, and we combine those as like terms. Then I'm solving for cosine. So I'm going to do 1 divided by 1.232. So if we do 1 divided by 1.232, it's going to simplify. So we don't normally do division and decimals together. So we're just going to divide that out, and it's still going to be an approximate number, but we're going to round that to 0.812. All right, so divide both sides by the 1.232 because we're trying to get cosine by itself. The next step would be to take the square root of both sides. So if you want to undo something squared, take the square root. So I'm going to do square root, and I can do square root of just this approximate number, or I can do second, and it'll substitute this number here up there. So you can see it's like 0.9009. So they've rounded that to 0.901. All right, they do have plus or minus because the cosine could be plus or minus. Remember, which quadrant it lies in determines whether it's positive or negative. All right, so it says what justifications can be given for the steps of the solution this plus this equals 1. All right, so I just kind of went through that explanation, so I feel like I did that. All we did was take the Pythagorean identity. We substituted what we solved for earlier for sine in place of the, we substituted cosine in place of sine because we rewrote it a little bit earlier. And then all we did was solve from there, and the reason we did that is because you can solve when you only have one variable. We're thinking of cosine theta as one variable, where if we have sine plus cosine, two variables, you can't solve for that. So what we have to do is substitute to make that easier. All right, so the terminal side of theta lies in quadrant 3, where cosine is negative. Remember, quadrant 3 goes left and down. So cosine is negative, and therefore sine is negative. All right, and remember before that came from looking at the restriction on the domain. It told us it lied between pi and 3/2 pi. So you have to know that that's 180 to 270, and that just indicates that it's in quadrant 3. All right, how do you know that the terminal side of theta lies in quadrant 3? Again, the domain describes the third quadrant. Okay, it don't have anything to do with the range or the tangent, just the domain. All right, that's all for task 3. If you have any questions, let me know.